Okay, so a number of you have asked me about question 10, so I'm just going to go through it with you just to give you a little explanation. So we've got the sketch shows a semicircle and diameter. The radius of the semicircle is r units. If the area of the figure and the perimeter of the figure are numerically equal, show that r equals 4 over pi plus 2. Okay, so the first thing we need to think about, and I always tell you this as well, is draw a picture of what's going on. So we have our semicircle, okay, which if you think about it is half the circle, and we've obviously got our diameter drawn on here to make it into a semicircle. Now, we're told in the question that the radius of the semicircle is r, okay, which would obviously mean that this part here then is the diameter, or we could call that 2r, and that's probably going to be a little bit more helpful. Okay, we're also told in the question that the area of this shape is equal to the perimeter of this shape. Okay, so that's what we know. Now, it's a semicircle. The area of a circle would be pi r squared, but it's a semicircle, so we're going to have a half of pi r squared for its area. The perimeter of this shape, well, we've got the curved part here, which is half of the circumference, plus we've got the flat bit along the bottom, which is the diameter, or 2 times the radius. Okay, so this is the equation that we're going to have to work with. Now, we can replace the circumference. We know that the circumference is pi times d. Okay, so we can replace that first of all. Now, at the moment, what we're working with here, this expression, this equation, we've got a half pi r squared for the area, we've got half of pi times d plus 2r for the perimeter, and we're being told in the question that we've got to make this look like, effectively, this, okay, r equals 4 over pi, plus 2. Now, first thing I notice is nowhere in that does it have a d. So let's get rid of that d. We know that the diameter is 2 times the radius. Okay, so I'm going to replace that. Everything else is staying the same at the moment, and that's what we've got. Now, this part here we can tidy up. A half of 2r is just 1r. So this is just pi times r, and I've got plus 2r, and over here I've still got a half of pi r squared. Now, still looking not particularly like this, although it's getting a wee bit closer. Next thing, let's just keep playing about with this and see where we get. Next thing I don't really like is this half. Okay, fractions make things awkward, so let's multiply both sides by 2. If I multiply this side by 2, I just get pi r squared. If I multiply that by 2, I get 2 pi r. And if I multiply this, I get 4r. It's starting to look a little bit better. There's a 4, there's a 4, there's a 2 and a 2. We've got some pi's. This r squared's now the thing that's causing us the problem. Okay, so what I'm going to do is I notice that on this side I can take out a common factor of r. Now, I could take out a common factor of 2 as well, but that's not going to help me, so I'm not going to do that. Okay, and on this side we've got pi r squared still. Now, we're trying to make this into an r, so if I divide both sides by r, then that'll cancel with that. So on this side I'm just left with 2 pi plus 4, and that will cancel with that, so we can lose one of the r's, so we're just left with pi r and 2 pi plus 4. Now, we're going to find out later on this year that's a wee bit dodgy, okay, but we're allowed to do it in this case, and I'll talk to you why about that later on this year. Now, we're getting pretty close. This is what we're aiming for. This is what we've got. We want r on its own. At the moment it's multiplied by pi, so let's divide it by pi. So I've got, they'll cancel, r equals 2 pi over pi plus 4 over pi. If we split it up, because these two are separate, so we probably want these two to be separate, the pi's will cancel there to leave me with 2, and I've still got my 4 over pi. And obviously in the question it was written the other way round, so let's just write it the other way round to finish.